Hi, and welcome to Chapter 16. In Chapter 16, we are going to discuss different ways that you can maintain your network. Make sure that your network stays safe and secure. Let's get started. As you can see from our roadmap, we're getting towards the end of the course. Maintaining our network is the middle of our administration section. We have 2 more chapters after this, and then we'll be ready for the test. A couple of different things on this slide to explain to you how to monitor both your server and your network as a whole. One of the most important things in any IT department is going to be your documentation and your diagrams. A lot of people think we don't really need to document it. We don't really need to make diagrams. They sit on a shelf and nobody really looks at them. But trust me, when you need to find some information, those diagrams and those documentations can be very, very useful. The lack thereof can actually cause you some significant problems. So, a couple of different informations about your diagram. First, we have 2 different versions of physical diagrams, the logical and the physical. So, an actual diagram that describes your network. A logical diagram describes how the data flows from one point to another. This is similar to what we've been designing with our packet tracer, being able to say, here's a router and it's connected to this computer, so on and so forth. It shows the logical diagram. The physical diagram is going to show you where in the building is the actual wiring and where are the actual devices located. Both of which are extremely important because if you know that a specific device is causing trouble, you need to know where in the building that device is. You also need to be able to recognize how other devices are related to each other in a logical diagram. So logical is going to be your flow of data. How is your data flowing from one device to another? As opposed to the physical is where is it in the building. The 4 little icons here across the top are important. They're actually, if I remember correctly, part of the Network Plus test. You have to know what they mean. So our router is going to be the arrows that point in and then point out. The firewall looks like a brick wall. Our workgroup switch, so anything like a switch, shows the arrows going to 4 different ports, 2 on one side and 2 on the other, and then obviously a workstation or a computer looks like a computer. Being able to recognize those icons, especially in a diagram, is going to be important. Remember when we think about our physical diagram and where things are located, remember that main distribution frame we talked about a while ago. That's where the outside lines enter into the premises, enter into the building. So our main distribution frame. The other is our intermediate distribution frame, which extends the main distribution frame into other rooms or other closets. So we can have intermediate distribution frames there, and then our main distribution frame being the main location where outside lines come in. Trying to remember where those are located. If you need to flip back to the previous chapters, feel free. When you make your documentation, you need to have change management documentation. What this does is it documents all of the changes you make to the system. Anytime you upgrade anything, anytime you change something, anytime you change a port, add a switch, add a router, change passwords, upgrades, patches, fixes. All of these need to be documented in your change management documentation. The reason why, of course, is because if something broke, you need a document to go back to say, when was it last working and what changed between those 2 things? Oh, look, I have added this switch here. Because I knew I added the switch, let's see if there's a problem with the switch. Let's check that out. Pull it out, check it out, put it back in, put a new one in, replace it. Whatever you need to do to figure out. But if you do not have that documentation, somebody else could modify a switch and not tell you, and then you have no idea where to even start looking. When you install your network the first time, you want to always establish a baseline. This is the base level of network activity going on. The little form that we have here is just an example from the book that shows different things you want to keep track of in your baseline report. Start with a baseline, and then we want to continually keep an eye on this. Once a week, once a month, once a day, depending on your server and your network usage. You want to keep an eye on these. Sometimes you want to run them multiple times during the day. You might want to run in the morning when everybody gets in the morning, in the middle of the day when everybody's working hard, and then of course in the evening when nobody's on. So you know what network usage looks like in all of those different situations. We want to test both normal and stressed conditions, or conditions where everybody's using the system, versus normal, a normal day, how everything's normally going. We look at two different pieces. We actually look at a lot of pieces of information, but two specific pieces of information, which is your utilization and your frame size. Utilization is how much is the network actually being used, how much traffic is going around. What is the average utilization and what is the highest utilization? You want to make sure that your network can handle both your peak loads and your normal loads. Normally, when you set up a network for the first time, you're going to look at your average utilization being around 15 to 20%. Pretty low, because it needs to grow with time, and that's normal. If your average gets to be above 40 to 50%, you might want to consider adding something, subnetting, being able to add new servers, so on and so forth. So you want to keep an eye on the highest level and the average level. If your highest level reaches above about 85%, you need to actually make some changes, because essentially you may end up with a point where your network cannot handle the load from your company. So the amount of people using it, the amount of usage, utilization. And then we also have our frame size peaks and averages. As we learned looking through Wireshark and different frames, we understand TCP, UDP, IP frames, Ethernet frames, they're all different frames. So they're all going to be different sizes. But what we need to look at is your TCP frames pretty consistent with their average frame size, or do they change significantly? Did your TCP frames drop off? Normally they're about 500 bytes, but if your TCP frame suddenly went down to 40 bytes, you might have a problem. So smaller than average TCP frames would be a problem. Each of your different protocols is going to have different frame types. You want to keep an eye on the different frame sizes on average and the different frame sizes peaked, just so that you can keep an eye on whether or not there's anything weird going on in your network. Is something being lost? Is there collisions? Is there packet losses? Both the frame size peak and average should be documented so that you can look back through this. So I'm going to do this on the 15th, and I'm going to do it again on the 20th, and then I'm going to do it again on the 25th, and I can compare and do trend lines to see how things are going. Is there suddenly a huge spike in certain protocols? Is there a reason for that? Does it make sense? So we took down our web server, so suddenly our HTTP amounts went down. Well, that made sense. We took down our web server. But if suddenly your port 80, your HTTP packets disappeared altogether, is there a problem with my website? Is there a problem with my server getting to it? Keep an eye on those, and it'll help you to maintain and monitor your network. With your server, we want to look at things like your memory utilization, your hard disk activity, your CPU usage, and how much the server is being accessed. These are more of tangible amounts that are going to say how much of the server is being used, rather than baseline for your network, which is how much traffic is moving back and forth. Each of these different things tells you something about how people are using your network. This is important. You need to know how your network's being used so you know where to plan in the future, what upgrades you need to do, what changes you need to make. Do you need to segment your network? Do you need to use a VLAN to virtualize it so that network traffic stays in a certain region? Do you need to add more servers? Do you need to add more routers? Does things need to change in your network? If you don't keep track of it, your network can fail without you even noticing. One quick little thing. When you have so you have your RAM. We've talked about RAM, your random access memory on your server. If the RAM is not significant enough, there are things called swap files or page files, which are on the hard disk, which supplement the RAM. It's just a piece of information to recognize when you're looking at your network. If you get to the point where your RAM usage is up in the 90s and the hundreds all the time, you're constantly probably using that swap file hanging out in the hard disk to be able to supplement your RAM. You need to add more RAM to your system, or you need to figure out why so much RAM is being used in that location. Another useful thing in the monitoring of the server is going to be monitoring which nodes are being used and how many collisions there are. If you have specific nodes that you know are going to be hitting all the time, that's great. You can keep an eye on those. What are the 10 most active nodes? If those change, if another node shows up, that could give you some idea that there is someone who's either using resources they're not usually using, or maybe someone bad has gotten in and is using some sort of a device on your network. So keep an eye also on those number of nodes. Also with the collisions, remember when we talk about collisions way back when, and we talked about how they occurred. If your network is too overloaded, you're going to end up with significant collisions, similar to a DOS attack. This will point that out to you and show you what's going on. Now, to find all of this information, you need to find some monitoring tools. So on a normal device, just a singular device, you can look up either your performance monitor or your resource monitor, both of which will show you how the device is being used. CPU utilization, memory, disk space, how it's being used across the network, how the network is being used. So it's important to keep an eye on these type of performance monitors when it comes to a singular device. Your resource monitor is going to do the same similar thing with your RAM and your CPU and your network, but it's going to break it down into which actual event is occurring. You also have event viewers, network monitors, and then of course the Simple Network Management Protocol, SNMP, which you can turn on, which will allow you to actually manage the entire network from a single location. So if you are in a position to manage your network, you're a network administrator, you want to have some sort of management protocol on your computer so that you can see the entire network, every device, all of the network options, to be able to keep track of that management of your network. Your operating system, your server operating system, things that are keeping track of your network, these are software, just like any piece of software. And sometimes in software there are bugs. There are errors in the software where the person who designed it made a mistake. And those bugs need to be resolved. Software manufacturers have created a couple of different ways to do that. The first is what they call patches. As soon as the vendor or the software manufacturer has found a bug, they usually can release a quick fix or a patch to solve that bug. If they can find it, they can resolve it. It may only be a few lines of code, quick compile, and push it out so that that bug is no longer there. These are patches. They're frequent. They're usually updates on software, but they're specifically designed to fix a specific problem. There is no overreaching, oh, let's add this new feature in patches. Patches are just about bug fixes. Service packs are usually collections of patches. So if I did 10 patches in 5 months, I may collect them all together and make them into a service pack, which means anybody who comes after this point and wants to install, they can just install the service pack instead of installing each patch one by one. Microsoft does this a lot. When the software company decides to upgrade, they make a significant improvement or enhancement. They have fixed something to the point where they have altered the actual software and made a major improvement. So this is not a patch for a fix or anything specifically. This is not a bug situation, although there may be bug fixes in upgrades. It is specifically designed to take the software as it sits and make it better. It's an enhancement to make it different. This could be altering interface options or altering the way that the database was designed in the back end or something like this. These are major improvements. They're not a single bug fix. When you are going to run either a patch or a service pack or even an upgrade, you always need to test it on a limited number of computers first. For obvious reasons, it's possible that it's not going to work nicely. You want to ensure that there's no problems or complications with the install. Most software vendors are going to provide a hardware or software compatibility requirement from that vendor, and they're going to say these hardware requirements are required for this update or this patch. If you don't have enough RAM, if you don't have enough free disk space, it'll usually warn you about that when you run the update or when you look at the compatibility requirements. Make sure that your computer, the server, your network is able to handle whatever the software update that they're adding is. If you have an older server, I mean, it may sound ridiculous, but if you have a server that's still running Server 2008 and you try to run an update to a software piece that requires 2012 or 2016, it may fail, and you really don't want your entire network to have to be rolled back. So we always test it on a small number of devices first, make sure it works nicely, that there's no complications, keep an eye on it for a couple of days, make sure that nothing changes over time, and then you can roll it out to the rest of your network. If you are changing a significant change to your operating system, I am switching from Linux to Microsoft, or I'm going from 2008 to 2016 for server, you need to do a migration before. So migrations refer to the ability to say, I have this current operating system, I need to migrate it as opposed to just upgrading. Upgrades are improvements or changes to a software version. 2016 has upgrades. That's fine. When you bump up to 2019, you might want to run a migration to make sure that all of the changes in 16 get migrated nicely. The concept of generally reviewing. You can use your security information event manager or any type of an event manager to look at your event logs. What happened every day? Event logs just keep track of every log of every occurrence that occurs. You can do port scanning software to make sure that individual ports keep track of things. You can just do basic monitoring. And at some point, you're going to want to run some version of vulnerability scanning. Vulnerability scanning is where you actually look around your network, try to find places where bad guys can come in, where there's vulnerabilities to outside information or even insider threats. We talked about this last chapter. Different security options. You want to do a vulnerability scan on your network and find out where you're vulnerable so that you know what you can fix. You may not be able to fix everything, but at least you know that the risk is there. As you can imagine, if the server is running 24/7, at some point it may fail. The amount of uptime generally can say at some point, this has just been too long. There's been too many hours that I've been running and I'm going to fail. So what we do is we schedule downtime. We give the servers a break and we let them shut down and we let them kind of reset and get everything back to normal. This can be a problem if you have memory leaks or if you have problems with software that can cause problems with your RAM or your hard disk. If you can shut them down, the RAM gets reset and that can clean things up, just like shutting down your personal computer every once in a while. When you schedule your downtime, obviously, if you have the option, you want to do it off hours. So if you have a company that works 8 to 5, you might want to do it at 9 p.m., maybe on a weekend, something like that. However, that doesn't always work in some important companies or high-risk companies where they have to have their server up 24/7. If they have international companies where there is no time that nobody's using it. In this case, you want to have a couple of different options. The first is called server clustering, being able to have multiple servers that duplicate each other. So single servers, when you do clustering, similar to the imagery here, node 1 could be shut down for 2 hours and then brought back up during a lull or downtime in your server usage. And node 2 can hold everything that needs to be done during that time because everything's shared. So server clustering allows you to take down a single server, repair it, keep an eye on it, do some testing on it, diagnostics, put it right back up, and the others can remain operational. In other words, you don't lose the ability for your clients to be able to access your network. We have the option of NIC teaming. Remember, NIC is your network interface card. When we have multiple network cards that work together. So NIC teaming, you have multiple cards, and they allow you to increase your throughput. If you have a single card that only has a specific throughput, if you put in 2 cards, you can have twice as much. The other option is similar to NIC teaming, which is port aggregation, being able to allow 2 ports to be combined to also increase throughput. If we have 2 ports, we can have twice as much data coming through that port. The other thing with system hardware is using the concept of a virtual LAN. Remember, virtual LANs, not virtual networks up in the cloud, but virtual LANs in that we have segmented your network into individual little LANs. So we have one big LAN that holds the entire network, or a WAN, whichever it is that you seem to have. And then we can break those down into this section of the office or this department, and we can virtualize those LANs. By segmenting your network, you actually limit the amount of traffic on each individual device, your switches, your routers, your hubs, anything that's in that device or in that virtual LAN, which means the individual lifespan of each of those devices can be increased. Obviously, if we have a hub that is being used by everything, it can get a huge amount of throughput through it, and it's constantly being used. Whereas if it's broken down into a virtual LAN and it's not used as significantly, it can increase its lifespan. So this also helps you to maintain your hardware. You want to make sure your server and your network don't break. Breaking is bad. However, things happen in life, and we know that. There is disasters, there's natural disasters, there's failed hard drives, there's things that can go wrong. You want to mitigate that as much as possible. You want to be prepared as much as possible for things that could go wrong. Same reason you have insurance. In the off chance that your house catches on fire, you want to have insurance on your network in case there's a fire in the server room, in case there's a problem somewhere, in case a hurricane or a flood comes in and you get water all through your network. You want to have some disaster recovery mitigation options. Okay, some people get disaster recovery and fault tolerance mixed up. Disaster recovery is the ability to restore or recover your system to the prior operating status after something bad happens. This is recovery from a natural disaster, recovery from a fire, recover from something bad happening in your network. How are we going to recover? That's your disaster recovery. When we talk about fault tolerance with RAID systems, you can go back to chapter 9 to reference to RAID systems if you'd forgotten which ones were which. With a fault-tolerant RAID system, we actually allow the fault or the bad thing to occur, and everything just keeps on going. There's no disaster because we were tolerant of the fact that faults happen. With fault tolerance, such as disk mirroring, we can allow for a failure in a single disk, but because the second disk mirrored it, everything continues to go on as normal, and nobody noticed that there was a problem. If you had a hurricane come through your building, everybody noticed. There's no way you could miss a disaster. But a fault-tolerant RAID system, no one may notice. You may notice, because you may notice that the throughput in one of your disks went down to 0 because it failed, and the other one picked up all the slack. But in general, the rest of your users shouldn't notice. So in a fault-tolerant system, nobody should notice that there was anything wrong. It just kept on working nicely. When we do our backups, we have 3 different types of backups that we can use. When you do your backup, make sure you always store your backup in a secure, climate-controlled, locked room, or in the cloud behind passwords, so on and so forth, so that those backups are safe and secure. 3 different types of backups we refer to. The first is a full backup. Full backup takes the most amount of time, the most amount of space, but is also the easiest to recover from. So if I do a full backup every day, that's obnoxious, the amount of space and time it's going to do a full backup. But if I have any failures, all I have to do is restore the full backup and I'm good. I'm back to normal. Most companies cannot do a full backup all the time, mostly because, again, the amount of time, downtime it takes to lock down the system for a full backup, they just don't have the time to do that. So they tend to do full backups incrementally. We're going to do a full backup on Sundays. We're going to do a full backup on the first of the month. We're going to do the full backup, every 3 months, every quarter, something like that. Full backups. Then we're going to do what we call incremental or differential backups. Okay, incremental backups back up everything that has changed since the last backup. They use what's called an archive bit to determine if anything has changed. So they look through all the files, and 90% of them probably haven't changed. So all we need to do is incrementally store the things that changed since the last backup. To fix a recovery, to recover from a backup with a full backup and incremental backups, you have to implement the full backup first, and then implement every incremental backup in order as they go. So if I had 5 incremental backups, say I did a full backup every Sunday and an incremental backup every day of the week. So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and then Sunday I did another full backup. If the system failed on Thursday, I would have to do the Sundays full backup and Mondays and Tuesdays and Wednesdays incremental backups, which could take some time to do. So there's some drawbacks to doing that. But of course, those incremental backups are a lot smaller than your full backup because all we had to do was back up just the things that had changed. A differential backup is actually all of the data that changed since the last full backup. Every differential backup holds everything, so it increases in sizing as it goes along. But it makes it easier to recover because if you had a differential backup every day, so you did your full backup on Sunday and a differential on Monday, Tuesday, Wednesday, Thursday, all I would have to do is my full and my Wednesday, because Wednesday already includes all of the backups from Monday and Tuesday, because it's everything that's been changed since Sunday. So the difference between full backups, incremental backups, and differential backups. It's important to keep track of when they are used and how they are used. When we have something to document, how the system is handling it. We can call them the mean time to repair and the mean time between failures. The mean time repair is the estimate of how long it takes from when something bad happens until you fixed it. It might be in minutes, it might be in seconds, it might be in days. Depends on how long it takes you to fix that. But it's an average. It's mean. Means are averages. So mean time to repair is how long does it usually take you to repair the system when something goes down. Your mean time between failures is how long is it between the last time something failed. This is kind of like those little charts that you see in some manufacturing that say we haven't had an accident since, 14 days ago. How long has it been since your last failure? So our mean time between failures, it could be that you only have a failure every 6 months. So it's okay that your mean time to repair is 4 days because you don't have them that often. But if you have failures every week, you want your mean time to repair being really quick so that you can get those resolved. So these are just two acronyms to keep track of your mean time, MT, to repair or between failures. There's also a service level agreement that usually your software vendor will provide that essentially says, if my system fails, how long do I have to wait before the vendor gets around to helping me? Sometimes you have vendors that will respond within hours or even, within 24 hours, sometimes within minutes, depends. A lot of vendors will do the 24, 48 hour issue because they just can't guarantee that kind of speed. And it really depends. If you fail on a Sunday night and they have no one to help you, they may not get back to you until Monday morning just because of business hours. When you have a backup, there are two different things that we're going to talk about here, and they're hot and cold. And then throw in warm just for kicks and grins. So we have our spare disk. Imagine that you have a disk failure. How do you handle a disk failure? Well, there's two different ways. We can have a hot spare or a cold spare. A hot spare is an actual disk sitting in your RAID system that is not actually in use. It can be flipped on instantly and immediately pick up everything it needs to do. But nobody's actually using it. It's kept up to date constantly, so it is constantly available, and at any moment you could just flip the switch to say, this RAID drive failed, this one's popping in there, it's a hot spare, and everything works just fine. That's a hot spare. A cold spare is a spare disk drive sitting in a storage room. There's nothing on it. It has to be installed and have all of the software that needs to be, or all the data that needs to be put on it before it can be put in. It could be hot swapped in as soon as it has everything loaded onto it. So if your spare disk literally is just an empty drive because you need a storage location, that's fine. A cold spare can just be popped in and used with hot swap bays being able to do that. If it's something that needs to have data on it, it might need to have information installed on it before it can be actually used. But it's not like you have to go to the store and buy a new drive. The drive is sitting there cold in the server room or in the storage unit waiting to be used. Same concept sort of with cold site, warm sites, and hot sites. When we have a cold site, this is what a lot of people do with their backups. We take our backups, we put them on a tape drive or a drive of some type, and we throw it in a storage unit. It's just sitting there. That's all it's doing. It's not attached to any devices. It's not plugged into anything. It is literally a drive sitting in a storage unit that I have to physically take out of the storage unit and go do something with. Those are cold sites. It's important to keep those because those could be older backups, maybe from multiple years that you needed to reference if something needed to come up, if you lost old data or older backups. Warm sites is where both the hardware and the data are stored in the same facility, but nothing's really installed yet. So we have our data and we have the hardware we need to actually use our data. So at least you can go into the storage site, grab the tape, put it in the hardware and hook it up. You still have to do it. But at least they're both in the same location. We call that a warm site because it takes a lot less effort. If you had a cold site, you have to go get the tape, bring it, do you have a server to use? Having the server and the tapes in the same location makes it a warm site. A hot site is where you have the server and the tape both running, constantly being updated. It's just not being used. So it's constantly getting updates from the current servers that are being used in your network, and it's just sitting there waiting for the off chance that one of the servers is going to fail, in which case I can just flip on a hot site, everything is loaded, everything is fine, everything is perfect, and my downtime was really, really low. Hot sites, they can be flipped on immediately. Cold sites, you have to do some significant effort. Warm sites, at least you have the server and the tape in the same location. The next thing we're going to talk about is power. Obviously, everything in computers, everything in networks is going to require some power. So we're going to reference a little bit about surges and spikes and brownouts, which we've already covered before, but just to remind you, a surge is higher than normal voltage. That doesn't mean that it's a significant amount of voltage. It just means that it's a higher than normal voltage. A spike is a very short burst of an abnormally high voltage. So spikes are just like, we're going to pop really quick and then it's going to go down, whereas surges are consistently higher than normal voltages. So they're both different types of voltages. Brownouts is where you lose some of your power, and blackouts are where you lose all of it. There's no power at all. When we have electrical surges during lightning, so lightning comes in and it causes a surge, we can use something called a lightning arrestor. It is specifically designed to prepare you for the electrical surge that comes from lightning itself. So that huge surge that you get. And it's important to be able to have that kind of a situation if your network is in a place where you get lots of lightning. When you think about having no power, most people will go with what's called a UPS. You can get a personal UPS, uninterruptible power supply that can sit under your desk, and it's essentially a battery backup. It ensures that you have constant or consistent power all the time, even if you get brownouts, even if you get blackouts. It will let you know if you've lost power so that you can at least shut down nicely instead of having everything just shut down, ugly. It also can do things called power conditioning. So power conditioning is where it purposely is looking at the amount of power and it will not allow any spikes to come through. It won't allow variations in your power signal. If too much power comes in, it handles that and it shuts it down immediately. So that's power conditioning. So if I expect 100 volts to be coming through and I get a spike or a surge that drops it up to 150, it just cuts off the remaining 30 or 50 volts and says we're still going to keep it at this 100 volts all the time. UPSs can be either standby or continuous. So we can have an offline or an online standby, or we can have a line interactive continuous. So when we talk about our standby, when we have our standby UPS, it is not actively connected to your power source. It has a relay that is turned off unless power fails. So the minute that power fails, it gets turned on. And that inverter is going to work with the battery and the charger will be connected the whole time, but the battery will not be actually sending power to your network until power is shut off. So we're just keeping a little sensor on there to find out whether or not we need to keep track of that. And then which service are we going to use? So those are standby. We can have them either online or offline. The line interactive is where the inverter actually exists in line with the battery and it's continuous, which means we have our power coming in. It's constantly recharging our battery, which is constantly being used to keep our server up. If at any point power fails, the battery will instantly take over because it's been there in the middle of the line anyway. So it means that the input coming from your power is suddenly going to stop going into the battery, but everything else will continue as it was going. If you set up your line interactive correctly, you will never notice lack of power because that battery will work just fine. The important thing to keep track of is making sure you do not let your battery get depleted. If your battery gets depleted, then everything fails. So it's important to keep track of that. A few more options with power. We do have the option of what we call an isolation transformer. An isolation transformer actually allows you to split the circuit, isolate the circuit from other circuits. The point of this is to be able to have your regular purpose power that is used for most normal things, your coffee maker or, your radio, things that you don't really need significantly. And then a more dedicated secondary wiring that is going to allow you to make your computer network services on a second set of power. By isolating that, you can make sure that the computer equipment is hooked up to the generator, whereas the main equipment isn't, or something along those lines. We sometimes call it primary or secondary, and they can just have dedicated outlets or even whole dedicated panels related to the secondary wiring. Obviously, as we know in Montana, we have generators. Generators actually create and produce energy 24/7, usually using some sort of fuel source to allow you to have uptime in the case that the power goes down. All right, so that's the end of chapter 16. There's a couple of review questions, a couple of study guide questions. For the lab activities, I'm only going to require 78 and 82 because 79 uses third-party software called Landsweeper. You're welcome to research it, look it up, find out what Landsweeper's around. If you want to install it, feel free. 80 is actually having you do a backup and a restore. I'm not going to ask you to back up and restore your own network. You can choose to, and I think it's a really important thing is to understand how backups and restores work. Obviously, I think it's great to have a backup, but I'm not going to require that as part of this course. 81 is an antivirus. Everybody has their personal preferences on antivirus. I'm not going to ask you to pick one. If you choose to have an antivirus, I recommend you pick one that you're happy with. But again, that's going to be an optional lab. You don't have to do that. It's just going to be searching and figuring out different programs. So 78 and 82, only 2 labs required. Don't forget to do the StudyMate if it's available, and or the StudyMate's available, and then don't forget to take your quiz. Thanks so much for tuning in to Chapter 16. Please come back next time for Chapter 17 to learn more about how to maintain your network. Have a great week.